Hi everyone, I will solve GATE 2023 Aerospace Engineering question number 57. In a potential flow, a uniform stream of strength U directed along the x-axis and four line forces, two-dimensional of strength pi by 2, minus pi by 3, pi by 4, minus pi by 5 are placed along the x-axis at x equal to 1, 0, 1, 2 and 3 respectively. The strength of an additional line force to be placed at x equal to 4 such that a closed streamline encircles all 5 forces is. Round off to 2 decimal places. This problem is related to potential flow. So if you want to know more about potential flow, you can refer to this NPTEL lecture. So in this problem, it is combination of two flow, uniform flow and line forces. So first we will know what is uniform flow. So uniform flow is the consist of a velocity field where v equal to ui cap plus vj cap is constant. So in this velocity field, velocity is constant. In 2D, this velocity field is specified either by the free stream velocity component u infinity v infinity or by the free stream speed v infinity and flow angle alpha. So either we need u infinity and v infinity, that is x and y component, or its magnitude v infinity and angle alpha. So u velocity is u infinity, which is v infinity cos alpha, and v equal to v infinity, which means v infinity sin alpha. So stream function is u infinity x plus u infinity y, which is v infinity x cos alpha plus y sin alpha. And stream function is x u infinity y minus v infinity x, which is v infinity y cos alpha minus x sin alpha. Now we will see what is source or sink. So in source, all the velocities outward from this source, and in the sink, all the velocity will be moved toward sink. So the radial and tangential component are to be defined to be, in this only component will be radial, so tangential component will be 0. And radial component defined by gamma upon 2 pi r, where gamma is the scaling constant called the source strength. This is called the strength of the source. Source strength gamma specifies the rate of volume flow issuing outward from the source. If gamma is positive, then the flow, it is called source, and if it is negative, then flow will be toward this source, toward this sink. So it is called sink. So this is the Cartesian representation of velocity. Here simply we have taken this r velocity in x and y direction. So we will get this, which is v equal to gamma upon 2 pi x upon x square plus y square, and v equal to gamma upon 2 pi y upon x square plus y square. Similarly, we can write stream function. We can write the velocity potential equal to gamma upon 2 pi log under root x square plus y square, which is equal to gamma upon 2 pi log r. This is in polar coordinate. So inversely, stream function is gamma upon 2 pi tan inverse y by x, which is gamma upon 2 pi theta in polar coordinate. So in all these formula, we have assumed that source or sink is at the origin. This is for at origin. If our source or sink is, let's say, at coordinate h comma k, then in all this formula we have to write, instead of x, x minus h, and instead of y, we have to write y minus k. If we substitute this, we will get the formula for source or sink at location h comma k. So now we will solve our problem. So in our problem, what is given, that there is uniform flow and there are source and sink at various locations. It is 0, 1, 2, 3 and 4. 0, 1, 2, 3 and 4. So their strengths are respectively pi by 2 minus pi by 3, pi by 4 minus pi by 5. And this strength we have to find. Let's assume it is gamma. And it is given that combination of all these potential will give to a closed streamline. So this is the closed streamline. So we first have to write what is the stream function. So stream function will be combination of all these, superposition of this all these, stream function of all these elementary flow. So for uniform flow we have seen that it will be u infinity y minus u infinity x. U infinity is 0. So u infinity will be, it is given that u. So uy will be the velocity potential for uniform flow. For this source at 0, it will be gamma upon 2 pi tan inverse y by x. So here gamma is pi by 2. Gamma upon 2 pi tan inverse y by x. For location 1, it will be minus pi by 3 into 2 pi tan inverse y by x minus 1. This is located at 1, 0. So we have substituted x to x minus 1 and y will remain same. Similarly for next source, pi by 4 into 2 pi tan inverse y by x minus 2. Next sink, minus pi by 5 into 2 pi tan inverse y by x minus 3. And the last which we have to find is plus gamma on 2 pi tan inverse y by x minus 4. So this is the stream function. So for the stagnation stream function, streamline, this stream function will be equal to 0. Because in this problem, one thing we know that this closed streamline encircled all 5 sources. So this, whatever this streamline encircle this, it means that there is at least one stagnation point, and this stagnation point streamline will have phi equal to 0. So this will pass from y equal to 0 point. There will be 2 points where y will be 0. So when we put this y equal to 0 here, then we will get this first term will be 0. Second term will be, we will cancel this pi by pi everywhere. So second term will be 1 by 4, and this tan inverse y by x, it can be 0 or pi, because y is 0, so tan inverse 0, it can be 0 or pi. So in all term, this y equal to 0, so all term, if you take 0, then all term will be 0, so it will automatically satisfy, so we cannot find anything. As there are 2 points, one for one it can be 0 and for other it can be pi, so we will take this tan inverse 0 equal to pi. Second term will be minus 1 by 6 pi. Third will be 1 by 8 pi. Fourth will be minus 1 by 10 pi. and the last term will be plus gamma upon 2 pi into pi. This sum is 0. So we can take this, pi to pi will cancel, so minus gamma upon 2 equal to pi 1 by 4 minus 1 by 6 plus 1 by 8 minus 1 by 10, or it can be written as gamma equal to pi minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5. We will take LCM, which will be 60, so it will be minus 30 plus 20 minus 15 plus 12, which will be equal to minus 13 pi by 16. So gamma is minus 13 pi by 16, which will be equal to minus 0.68068. So we have to round off to 2 digits, so answer will be minus 0.68. This will be the answer. Thank you.